Okay, so let's turn this up now another notch and ask an even more complex question. Right, something to get us past even this first of the Nobel Prizes. That was the first one. We've got two more to go. So here's my next question for you guys. What about 3 bumps? So if I have 3 bumps, I'm talking about a potential that's going to look like this, V of x. I will have again my first bump that we had before, with, of course, the same width as always and the same height. And then I'll put, some amount of spacing. And to keep things simple, we'll always keep the same amount of spacing between them. My next bump of exactly the same size and width as the first bump. And then finally, after another equal distance, capital L, I'm going to put the third bump. So the question is now, how can we handle this series? Now, the first thing that may occur to you, which is certainly a great idea, is once again, we are going to certainly renormalize. We certainly can treat these bumps here, each as a unit with its own T and R, right? So this has a T and R, this has a T and R associated with it, and this has a T and R associated with it. Now, if I do that, that's going to help quite a lot, but I still have a problem because now I have 3 different centers about which I can form all kinds of different scattering patterns. And if I just lump them here like this, I'm still going to end up with an uncountably infinite number of diagrams. So there needs to be some other clever way that I could handle this system. And you might want to pause a little bit to think about what that might be. Okay, well, the basic idea here is we can repeat the same idea that we just had, except now, instead of making the 2 units an equal bump, we can actually combine these 2 and renormalize these 2 together into a net double scatterer unit, and then this into a single scatterer unit. So the net transmission and reflection here are going to be my T2 and my R2, which actually are things that I've already solved for. And then this scatter over here, of course, is going to be a T and an R by itself. Now, I think we've done this enough times. We should be able to now just write down what the final result will be for 3 of these. It follows exactly the same pattern, except now the 2 scatterers, instead of being identical, are a little bit different. So let's look again at our general 2 scatterer formula that we started with, right? It's going to make this type of a series, except now the T plus, which is the first thing that I hit, is what I'm currently calling T2. P is, of course, what I'm calling P prime. And then the T minus in this formula is the transmission through this downward step at the end of the row, and that would just be then like a single T. So we can then get our diagram, I think, pretty readily, or our result. So it's going to be transmission through the first unit, which is actually a T2, propagation across this gap, this is going to be my lowest order diagram, times transmission through the piece on the right, so that would be T, and then that's, of course, that's the first term, and then the infinite series is when I divide that by 1 minus the ricochet factor, which now involves first piece of the ricochet is reflecting off of this unit, so that's capital R, propagating back across the distance L, which we call P prime. Then the ricochet has a reflection off of this unit, which is an R2. And fortunately, again, right, this is a symmetric, this double well thing is symmetric, so therefore the reflection hitting it from the left and the right are going to be the same result. So I can use this R2 again, and then finally I have to propagate back across. So that's T3. R3, very similar case. Remember, so for R3, the first term is always exceptional. That's when you just bounce off of the first unit. So that will give me an R2. And then added to that is going to be an infinite series. The first term in that series is where I come through here, bounce off the far side, and then come all the way back through. That will be the first term in the series, which will go into my numerator. So that first term then is transmit across the first unit, T2, propagate across the middle, P prime, reflect off the right-hand side, R, propagate backwards across the L distance, so that's P prime, and then finally transmit out through that second unit. So there's another T2. It's actually T2 squared is the factor that it will appear on top. The denominator is then 1 minus the ricochet factor, and it's the same ricochet factor for both transmission and reflection. It's reflection off of this side, R, then P prime to bounce back, then an R2 to bounce forward, and then a P prime, like so. Terrific. So that is 3 bumps.